right, so this example problem is going to look at if I have a situation that I'm making an observation about an object in simple harmonic motion. How do I determine its frequency and its period? Some of these characteristic descriptors of the simple harmonic motion. So let's imagine that you are at your niece's house, and your sister's house. She just had a baby niece, and you bring that young baby a toy that sits above her crib and oscillates up and down. It makes her giggle. All right, so we have this toy on a spring. Let's see, it's a little monkey on the spring, and it's oscillating up and down. And you notice that the toy is oscillating you observe 30 cycles. So it's going up and down 30 cycles in 45 seconds. So you're sitting there watching her giggle with delight. You start to count the number of cycles it's going, and notice in 45 seconds it makes 30 cycles. What is the frequency of this toy, and what is the period? All right, so remember, frequency is equal to the number of cycles in the amount of time. So we have 30 cycles in 45 seconds. And so our frequency of this toy bouncing up and down on the spring is 30 divided by 45. I should have been able to do that in my head. 667 hertz. So cycles per second. So rounding to the appropriate number of significant figures, we get 0.7 hertz. All right. Now, the period, remember, is equal to 1 over the frequency. So we have, I'm going to use the non-rounded number. We have 1 divided by 0.667. Also, it's rounded, but it's at least not to the where it's going to influence my calculation. 1 divided by 0.667, and we get a period of 1.49 seconds, 1.5 seconds. All right, so it takes 1.5 seconds for it to oscillate up and down. Pretty slow toy that you're observing, and it has a frequency of 0.7 hertz. So using the information of our observation to give some information about this periodic motion or simple harmonic motion.